So we were saying or speaking about something called as a closed surface. No, the closed surface has a name, which is called as the Gaussian surface. So what does this Gaussian surface speak is? It is basically a closed imaginary surface. It's an imaginary one. It's a closed imaginary surface, right? And it's a three-dimensional figure. So the closed surface which we consider no around the charge distribution will always be a three-dimensional figure. And the most important point which I wanted to state here is, whenever you are applying this concept of Gauss law, it depends only on the charge that is enclosed within the surface, right? It depends only on the total charge that is enclosed within the surface. So that's what they're saying. See, Gauss law tells us that the flux through any closed surface S depends only on whom? Only on the value of the net charge that is present inside the surface, and it does not depend on the location of charges at all. So if you take a Gaussian surface, inside the Gaussian surface, if you know what is the value of net charge that is present, that is more than sufficient for you to apply this Gauss law. Okay, let me take an example and explain it. Suppose I have a surface like this, Gaussian surface like this. If I take this to be the positive charge, okay, and let's say this value is Q, right? Now, due to this, how is the electric field going to be? It is going to be in the radially outward direction. Right. If I ask you what is going to be the flux through this, what will you write it as? Flux through this is 1 by epsilon naught times the total charge that is present within the surface, which is Q. Done. This is what Gauss law says. Right. Now I have a question. If I take this radius to be R, if I increase the radius from R to 2R, then what is going to be the value of flux? If I increase the radius from R to 2R, right, then what is going to be the, sorry? So what should be the value of flux? It should be the same value, right? It is Q divided by epsilon naught. One major confusion that happens here is people start connecting it with E dot A, electric field into area. No, since the area is increasing, they will think flux is also increasing, but nothing will happen, because what does Gauss law state? The flux through the surface depends only on the net charge that is present inside. It doesn't even depend on the location of it. When you know that the net charge present is Q, whether you take a Gaussian surface of R, 2R, 3R, 5R, whatever R, the flux value is fixed. This is a very important question. Most of the times they'll ask you. Okay, this is one thing. Secondly, if I take another system like this, let's say I have charge Q1 minus Q2, Q3 present like this, right? Q4 and Q5, okay, negative of Q5. Then what is going to be the flux through this? So flux will be equal to Q1 minus Q2 plus Q3 divided by, so another important point to be noted is the total flux depends only on the charge that is present inside the Gaussian surface. Whatever is the charge outside the Gaussian surface will not contribute to the flux at all. So that's what the second point is. Charges outside the surface will not contribute to the flux at all. And secondly, what did we do here? I didn't write it as Q1 plus Q2 plus Q3. I wrote it as Q1 minus Q2 plus Q3. What property of charge did we apply? It's additive nature of charge. So we applied the additive nature of charge. Am I clear with this? Right? So this is all about the Gaussian surface and the important points related to Gauss law. Right? So please make a note of it.